Well, welcome. I'm continuing on with derivatives and logarithmic differentiation. And I've highlighted in blue here the log rules, which I've talked about in previous videos, where you are rewriting logs using your log rules. And then I've written it down here again, where I've got the natural log using the same kind of rules. I've also repeated what we've done before, the derivative of y equals natural log of u is going to be y prime is going to be 1 over u times u prime. Okay? And I've got change of base formula here, which I've asked you to put on your card, where if I have log, let me highlight this, log base a of x, I can write it with natural logs. So I'm just going to do an example. Log base 4 of 3, I can convert that as the natural log of 3 over the natural log of 4. They mean the same thing, and we will use that at certain times. And then the derivative of log, so if I have y equals log base a of u, y prime is going to be 1 over u natural log of a times u prime. So these are all repeats. I just wanted you to have them for your notes and make sure they're on your derivative card. Now let's practice doing some derivatives using logs, and logs are in here, by the way, so I'm going to show you how this is so easy to derive now that we know our log derivatives. So these examples actually involve a log of a certain base or the natural log of a function. Okay, you can use log or natural log rules, if you will, to make life easier. So I'm just going to do a couple problems here to show you, and this is a method, all right, that works really well. So natural log is in here, so I know I can use log rules. So I look at it here and say, well, I can actually, and notice I am not using y prime, rewrite this using log rules. And so here, if we were doing this normally, you would say, oh, I have to do the derivative of the outside and then do the derivative of the inside. But before we even do that, or we might not have to do that, is just rewrite it using log rules. So here I have inside here a 1 divided by x times the radical x plus 1. Let's rewrite it using log rules. So this is the same thing, the natural log of 1, and since I'm dividing, minus the natural log of x, okay, radical x plus 1. So I'm going to go in baby steps. So far I can say that. And then I can even rewrite it to say, okay, that's the natural log of 1. Then I can say, well, inside here is multiplication. I can write it this way, minus the natural log of x. And then because it's multiplying in here, it's a plus, but since it's a minus here, it's going to go through here. So I'm basically, well, let's go in steps. I don't want to confuse you. So let's start this like this. I can do minus, all right, and then I'm going to put a parentheses here. Then you'll see what I'm talking about. The natural log of x plus the natural log of, and we're going to rewrite this as x plus 1 to the 1/2. So you can see that. Now what I was trying to say before is now I have to distribute this negative for here and here. So it's really y equals the natural log of 1 minus the natural log of x. And because I'm distributing the negative, it's minus 1/2 the natural log of x plus 1. Okay, so notice this is not the derivative. I did not do the derivative at all. All I did was use log rules and expand this. Now, because the derivative of y equals natural log of u is y prime is 1 over u times u prime, because that's such an easy and nice derivative, I can take the derivative this way. So I can say y prime is going to be, the natural log of 1 is going to be 0, okay? And this is the natural log of x, so this is going to be minus 1 over x. And then here, it's going to be minus 1/2 times 1 over x plus 1. So right here and here, I use the natural log derivative. And look what I got. The derivative was easy to do. Now basically, I'm going to spend time just rewriting this a little bit because I don't need that 0. So it's going to be minus 1 over x minus 1 over 2 times x plus 1. So that really is the derivative right there. But now you'll see where lots of times when you check your answer that they've done some algebra, and a lot of it is just combining these fractions. So here I've got a fraction minus another fraction, so let's find a common denominator. So my common denominator is going to be 2x times x plus 1. So the first one I'm going to multiply by 2x plus 1, and when I get that, I get a negative 2 times x plus 1. And then here I'm just missing an x, so I'm going to do minus x, which comes out to be negative 2x minus 2 minus x all over 2x times x plus 1. And that comes out to be minus 3x minus 2 all over 2x times x plus 1. So what I ended up with right here for the derivative, this is the same thing. All I did from here over to here was just do algebra, so it was one fraction. Okay, let's look at the second one. Now if we had to do this the normal way that we've been doing this, you would be doing this forever. So I think I'm going to use log rules and try to expand this first before I take the derivative, because it seems to be easier. So we're just rewriting this using log rules. So I'm going to go slow. Inside is division, so I'm going to do this is a natural log of x squared plus 1 to the 5th minus the natural log of, and I'm just going to write this as 1 minus x to the half, because I know I've got to do this anyway, so that's a quick thing to do. Now I'm going to bring down my exponent, so this is really y equals 5 natural log of x squared plus 1 minus 1/2 the natural log of 1 minus x. Now I've just expanded it. I have not done the derivative. Now I'm doing the derivative. So y prime is 5, the derivative of natural log is times 1 over u times u prime, which inside is going to be 2x, minus 1/2 times 1 over 1 minus x, and the derivative of negative x is negative 1. Still got to do the chain rule, guys. So you have y prime is going to be, let's look at this one, 10x over x squared plus 1 minus, actually it turns plus because I have a negative times a negative, plus 1 over 2 times 1 minus x. That is the derivative. Now we're going to spend time doing some algebra to see if I can get one fraction. So the common denominator is going to be 2 times x squared plus 1 times 1 minus x. So what am I lacking here? What's my smart one going to be? It's going to be 2 times 1 minus x. So I'm going to do 2 times 10x times 1 minus x. That's my first term. Plus, and what am I missing here is x squared plus 1. So I got x squared plus 1. And now I'm just going to do some algebra here. So this is actually going to be 20x right here. I'm going to multiply this times that. And then it's going to be minus 20x squared plus x squared plus 1 all over 2 times x squared plus 1 times 1 minus x. And then the final is going to be negative 19x squared plus 20x plus 1 all over 2 times x squared plus 1 times 1 minus x. So there is our final. There's our final after we have done some algebra. But this really is this right here with a common denominator. Okay, that's going to finish this video, and then I'm going to show you some other kind of logarithmic differentiation in the next video.